लो सर, चलो हाँ, पेन भी ऐसा नहीं बहुत लोगों का पेन है, नहीं तो यहाँ तो पेन मिलते ही नहीं। ए, इधर बैठ, आओ चुप हो जाओ, इधर बैठो, बैठो, इधर बैठ जाओ, एसी बंद करके आओ इधर, और ध्यान से सुनो अब। जिंदा तो कुछ नहीं हो, तुम लोग मर ही चुके हो बस। आपने जान लिया। पानी इधर तक नहीं आता सूरज, फोटो बना के डुबा दे। हेलो, गुड मॉर्निंग।
Good morning, sir.
सूरज को हटा के उधर बैठ, सूरज भी उधर बैठने दे। Today's topic is electric dipole. We have done electric field and electric field lines. Chapter 1. Electric charges and fields. And topic is electric dipole. Yes. What is electric dipole? चार्ज को इंफिनिटी से इसको फील्ड बनाने के लिए पावर निकल नहीं, क्या बात है, बहुत मसाला डाल दिया। जरा आप बताओ, आपको दर्द नहीं होता? बताओ, होता ना दर्द? इलेक्ट्रिक डाइपोल, बताओ, चलो फॉर्मूला ही बता दो। इसलिए बोल रहा था मैंने कि मर चुके हो तुम लोग, जिंदा नहीं हो। जिंदा लोग को तो एहसास होता है, तुम लोगों को एहसास ही नहीं है। वेरी पोर। चलो ध्यान से सुनेंगे। ऑनलाइन स्टूडेंट्स, डू यू नो व्हाट इज इलेक्ट्रिक डाइपोल? यस और नो?
No, sir.
ओके, इलेक्ट्रिक डाइपोल इलेक्ट्रिक डाइपोल is an arrangement or I would say electric dipole is a system of two charges, is a system of two charges of same magnitude, two charges of same magnitude but opposite polarity, but opposite polarity, placed at placed at a distance. Okay, so let's say we have two charges. This is charge q1, and at certain distance there is another charge q2. So this system will be an electric dipole if first point, magnitude of charge q1 is same as magnitude of charge q2. Let me call it q. And the second condition is both the charges has opposite polarity. So if both of them have opposite polarity, it means q1 multiplied q2 will be greater than 0 or less than 0. If charges q1 and q2 are of opposite polarity, what will be their product? Greater than 0 or less than 0? Less than 0. So q1 q2 is less than 0. This implies that if q1 charge is minus q, then q2 charge will be plus q. Yes or no? If q1 charge is minus q, q2 charge will be plus q. So this arrangement is known as what? This arrangement is known as electric dipole. So in electric dipole, we will have two charges of equal magnitude, q and q, with opposite polarity. One charge will be with negative sign, another one will be with positive sign. And there will be a separation between them. Let me call this separation as R. In some book, it is given by 2L. 2L is taken for the convenience in calculation. To make calculation easy, we have selected 2L. Otherwise, you can simply have it R or D also. So this arrangement or this system of two charges with same magnitude but with opposite polarity are known as what? Electric dipole. We can have some example for it. Let's say we have HF molecule. If you will look at the HF molecule, its structure is H bond F. And between hydrogen and fluorine, fluorine is far more electronegative than hydrogen, which means electronegativity of fluorine atom is greater than hydrogen. So bonded electrons will be shifted towards fluorine atom, due to which fluorine atom will have del minus and hydrogen atom will have del plus. So this arrangement will be a electric dipole because we have uh, two charges with same magnitude, del plus and del minus, with opposite polarity. If the charge on fluorine is, let's say, alpha coulomb, then charge on hydrogen will also be alpha coulomb. Polarity will be opposite. If fluorine is negative, at hydrogen we will have positive polarity. So HF molecule is an example of electric dipole. Same as HF, we can have other molecules also, like HCl molecule or HBr molecule. H2O can also be considered as a arrangement of dipole. And there are some molecules on the other hand which are not electric dipole. For example, H2. H2 molecule, if you will look at H2 molecule, H2 molecule is H bond H. In this case, both the atoms are of same electronegativity. So bonded electron will be exactly in between them and there will be no shifting in the bonded electrons. which means there will be no del plus or del minus, and in this case dipole is not going to be there. Okay, but in HF molecule we will have. So in this case we can say that there are two types of molecules. First one which have dipole, and the second one which do not have dipole. HF, HCl, HBr, Hi are the examples for dipole moment. Hydrogen molecule H2, iodine molecule I2 are the examples with no dipole. CO2 is also a good example. CO2 is again a molecule in which there is no dipole moment is present. Now for the dipole, electric dipole, we will define a quantity or a characteristic property of electric dipole which is known as electric dipole moment. Electric dipole moment. Electric dipole moment. Could anyone define it? What is electric dipole moment? No idea. Okay. Electric dipole moment is defined as the electric dipole moment is defined as the is defined as the product of कुछ भी is defined as the product of charge with distance between the charges. Between the charges. So from the electric dipole, if we will take any one of the charge and we will multiply it with the distance between the charges, we will get a quantity, and that quantity is known as electric dipole moment. This quantity is represented by P. It is represented by P. Okay. So the quantity P, which is electric dipole moment, let me write it as electric dipole moment given by P, will be charge, any one of the charge, multiply distance between the charges. So P will be charge Q multiply distance R, and if R is taken equals to 12, P will be Q into 12. So this is the formula for electric dipole moment. Another important point about electric dipole moment, its nature. So what do you think? It is scalar quantity or vector quantity? Electric dipole moment is vector or scalar? बोथ वेक्टर और स्केलर कैसे होता है मुझे बताओ जरा. Is vector quantity, and if it is a vector quantity it must have a direction. It must has direction. क्या डायरेक्शन होगा? Direction of P is from negative charge to positive charge in physics. And if you will take the same concept in chemistry, it will be opposite, positive to negative. दोनों ठीक है, ये ध्यान रखना. So electric dipole moment is a vector quantity. Its direction is given from from negative charge to positive charge in physics, and from positive charge to negative charge in chemistry. But right now we are in physics, so we will focus on the direction as negative to positive. Okay, another important point regarding this concept is this is minus q, this is plus q. Separation between them is, let's say, 2L, which means R is equals to 2L. Now, this line along which these charges are placed, this line is known as dipole axis. This line is what? Dipole axis. And dipole moment is q into 2L. Direction is from negative to positive charge. So direction of P will be given like this, from negative to positive. That will be P bar. So P bar is equals to q into 2L bar, because P is a vector quantity and P is a product of charge and, I would say, separation 2L. Charge is not vector quantity. Charge is a scalar quantity. It means direction will be given to the L, because charge is scalar. I cannot give direction to the charge. So the direction of dipole moment P is the direction of L bar. L vector means. So in this case, L vector will always be taken from negative to positive. So remember that direction of P is given as direction of L bar, and this direction is from negative to, okay. And the line along which this arrangement is placed is known as dipole axis. If you will take another line which is perpendicular to the dipole and which is passing through the midpoint of the dipole. Midpoint of the dipole is center of the dipole also. So let me give it in this way. Let's say this is minus q, this is plus q, and this is the midpoint. Midpoint of the dipole, we call it center of the dipole. If there is a line which is passing through this point and which is perpendicular to the dipole axis, remember this one is what? Dipole axis. Dipole axis. So we have a line which is passing through the midpoint of the dipole. So this will be L unit, this will be L unit, because total length is 2L. And if it is midpoint, then we will have L on one side and L on another side. So this line which is passing through the midpoint and is perpendicular to the dipole axis is known as equatorial axis. Equatorial axis. Okay. Any doubt in it regarding formula, definition, and nature vector? Let's discuss about its dimension. What do you think? What will be its dimensional formula? Dimensional formula. P is equals to Q into 2L. So dimensions for P will be dimensions of Q and dimensions of 2L quantity. What are the dimensions of charge Q? No. Dimensions of charge Q, 80. Dimensions for 2L. 2L is a distance or length. So dimension will be L. Yes. So dipole moment P will have dimension LAT. Yes. Okay. What do you think about its SI unit? What will be the SI unit? Charge in SI system has unit coulomb and distance in SI system has unit meter. So SI unit of dipole moment will be coulomb meter. Are you getting it or any doubt? Okay. So one part of the topic is completed, in which we have discussed about the definition of electric dipole, then a quantity related to electric dipole, which is dipole moment, and nature of dipole moment, vector, its SI unit, its dimensional formula, dipole axis, equatorial axis, and center of the dipole. Center of the dipole means midpoint of the dipole. Are you getting it? Okay. Okay, could someone tell me what is the total charge of the electric dipole? Net charge. Net charge of the dipole. So we can give it as Q net is equals to plus Q charge plus minus Q charge. So net charge will be 0 coulomb. Yes or no? Yes or no? Okay. Now we will discuss another concept related to the dipole, which is we have a dipole in 3D space, and we want to find out the strength of electric field due to this dipole at a point on the dipole axis at a distance r from the center of the dipole. Okay, two important points are there. First point is we are interested in the electric field at the dipole axis, first point. And the second point is all the references for the calculation will be considered from the center of the dipole. So distance of the point of interest at which we are going to find out electric field due to this system, that distance will be taken from the center of the dipole, and we are calling this distance as r. So let's try to find out what will be the electric field at the dipole axis along with its direction, because electric field is vector quantity. So we have to find out its magnitude also and direction also. So heading will be electric field E due to electric dipole. Due to electric dipole at a point on the dipole axis. At a point on the dipole axis. Okay. So let us consider a dipole. Let us consider an electric dipole. An electric dipole. As given in figure. As given in figure. Okay. Another information about the dipole is if you are looking for the charge, it's Q, and separation is taken as 12. So let's say this is the dipole. This charge is minus Q and this charge is plus Q. We are taking the point of interest on dipole axis. So let me have dipole axis. I already told you what is dipole axis. Dipole axis is the line. Dipole axis is the line on which dipole is placed, or joining two charges. You can also say that dipole axis is the line which is joining the charge minus Q and plus Q of the dipole. So this will be the dipole axis represented by dash, dash, and dash. Okay, this is dipole axis. And let's say point of interest is P. Let's say point of interest P is at this position. Red mark is point P. Okay, and I already told you all the references will be made from the center of the dipole. So whatever you will consider as distance, it will be considered from the center. So this point P is at a distance of r from the center of the dipole. So if this is the center of dipole, this distance will be L, this distance will be L. And from here, from this point to the point P, this distance is R. Okay. So distance of the point of interest is taken from the center of the dipole. Understood? तो ये ध्यान रखना है, जब ये फॉर्मूला बन के बाहर आएगा तो आर पता होना चाहिए हमें कि यार हमने कहां से मेजर करके लिया है डेरिवेशन में. सो आर इज टेकन फ्रॉम द सेंटर ऑफ द डाइपोल, क्योंकि क्वेश्चन फ्रेम करने वाला ये भी फ्रेम कर सकता है कि जो पॉइंट ऑफ इंटरेस्ट है वो पॉजिटिव चार्ज से इतनी डिस्टेंस पर है और आपने उसे आर पकड़ लिया और फॉर्मूले में रख दिया, तो यूजलेस है, पूरा गलत है वो. सो आर इज टेकन फ्रॉम द सेंटर ऑफ द डाइपोल. अंडरस्टूड? Okay. Now let me try to find out distance between point P and the charge plus Q. So what do you think according to the arrangement? What will be this distance? This complete distance is R. From this point to this point, complete distance is R. This gap is L. So remaining part will be R minus L. Yes or no? And if you will look at the distance of point P from the negative charge minus Q, it will be R plus L. Yes or no? Okay. Now let us consider the electric field due to these two charges, plus Q and minus Q. So I will write it as electric field. Electric field due to plus Q charge. Due to plus Q charge, let me call it E1 electric field. Okay. Electric field due to plus Q charge is given by E1. So what will be the magnitude of E1? Yes. Magnitude of E1. What is the formula for electric field due to a point charge? Yes, anyone? Online students? Electric field due to a point charge at a point P at distance R. किसी को formula याद है? Electric field E due to a point charge at a distance R. Again established. Yes? Okay. वैक्यूम कंसिडर कर लो. क्या बोला? ये कहीं से भी सही नहीं है. Anyone? No one? Electric field due to positive charge plus Q at a distance R is given by 1 upon 4 pi epsilon naught interested charge divided by distance squared. So according to this formula, what is my source charge? That is plus Q. And what is the distance according to this source charge? That is R minus L. So the value of E1 will be K Q divided by R minus L to the whole square. Are you getting it? This is the magnitude of E1. But again, electric field is a vector quantity. So you have to be careful about direction also. So what is the direction of E1? Yes. Direction of E1 at point P. This is point P. What is the direction of E1 at point P? This is the arrangement. Charge is positive plus Q and point of interest is P. So what will be the direction of electric field given by plus Q charge at point P? Rightwards to the point P. Why? because positive charge will originate electric field lines outwards. So the value of the direction of E1 will be in this direction. Are you getting it? Yes or no? So this is E1 vector. This is E1. Okay? Yes or no? बेटे मोबाइल बंद कर दो, ये आता जाता तुम लोगों को कुछ है नहीं, अभी तुमसे फॉर्मूला पूछा वो तुम्हें याद नहीं था और तुम लोग मोबाइल में लगे हुए हो। इतने गधे कैसे हो सकते हो तुम? इतना गधा तो गधा भी ना होता, उसे भी सेंस होता है मुझे क्या करना। तो डायरेक्शन ऑफ E1 फील्ड इज इन दिस डायरेक्शन, और तब ये हाल है, तुमने पढ़ रखा है चैप्टर ऑलरेडी एक बार। Okay, next charge we have in the system minus Q. So we will find out electric field due to minus Q charge. Electric field due to minus Q charge. Let me give this electric field by E2. So this will be KQ by R square according to the formula. K, what is the source charge? That is Q, because magnitude is same, but distance is different in this case. Distance for the source charge minus Q and the point P is R plus L. So this will be R plus L to the whole square. Okay. Now look at the formula of E1 and at E2 and tell me which one will be the greater in magnitude, E1 or E2. E1 is greater in magnitude, and why is it so? What is the reason that E1 is greater than E2? K is same, Q is same. So there is only one quantity which will decide about the magnitude, that is R minus L and R plus L. R minus L is a smaller quantity as compared to R plus L. And if in division you are having a smaller number, output will be a bigger one. So if it is divided by R minus L, E1 will be greater, and when you are dividing R plus L, dividing by R plus L, E2 will be a smaller one. So between E1 and E2, E1 will be greater. Yes or no? So E1 is greater and E2 is smaller. What will be the direction of E2? Direction of electric field E2 at point P. This will be inward in this direction. Okay. So if you will give the direction at this point, this will be in this direction. This one is E2. Remember or look at the figure, you will notice that E1 has a longer arrow and E2 has a smaller arrow. Length of the arrow indicates magnitude in vector. So longer arrow means magnitude of E1 is greater than magnitude of E2, because length of arrow for E2 is smaller. Are you getting this point? ये वेक्टर का बेसिक है, yes or no? Okay, so E1 is greater than E2 in magnitude. So in which direction you will have the net electric field? Yes. बेटे तुम लोग सच में डूब के मर जाओ भाई। एक डायरेक्शन में 10 न्यूटन लग रहा, एक में लग रहा 5 न्यूटन, तो रिजल्टेंट किधर आएगा? तो वही तो पूछ रहा हूं। What will be the direction of net electric field? Outward. Yes or no? Yes or no? Yes. So net electric field. Net electric field. Net electric field. Arrangement is like this. This is the point. This direction E1. And in this direction we have E2. Obviously, E1 magnitude wise greater than E2. So net electric field E net will be given by magnitude wise E1 minus E2. Okay, what is the value of E1? KQ by R minus L to the whole square minus E2. KQ by R plus L to the whole square. If you will take KQ common, E net equals to KQ common in bracket. We will have 1 minus 1 over R minus L to the whole square minus 1 over R plus L to the whole square. And if you will arrange this, you will get KQ. In denominator, it will be R minus L into R plus L to the whole square. Yes or no? Yes or no? And in numerator, it will be R plus L to the whole square minus R minus L to the whole square. Yes or no? Okay. Now look at it. It will be E net is equals to KQ. In denominator, it will be R square minus L square to the whole square. Right? And if you will simplify this one, if you will simplify the numerator, it will be A square minus B square. A square minus B square will be A plus B into A minus B. So what will be A plus B? A plus B will be R plus L plus R minus L, which means it will be 2R. Yes or no? And R minus L will be what? R plus L minus R plus L. That will be, I think, 2L. Yes or no? Yes or no? कुछ नहीं समझ में आ रहा, तुम्हें बुत की तरह बैठे हुए हो, मुझे ही करना पड़ेगा। भगवान सद्बुद्धि दे इन्हें यार। So let's say this quantity is A and this quantity is B. So according to the concept, it will be A plus L, A plus B. So plus R minus L, A plus B into A minus B, R plus L minus R plus L, A plus B, A minus B. This will be KQ. In bracket, L will cancel out. This will be 2R into R will cancel out. This will be 12. Okay. And divided by R square minus L square to the whole square. So finally result for E net is K, that is 1 upon 4 pi epsilon naught into charge Q into 2L into 2R, 2R, 2R divided by R square minus L square to the whole square. Okay. Now from the definition of dipole moment, P is given by Q into 2L. So in place of Q into 2L, we can have P. So E net will be 1 upon 4 pi epsilon naught multiply 2P into R divided by R square minus L square to the whole square. This formula is valid for all type of cases. All type of cases can be dealt with this formula. But if there is a special case is if, let's say, point of interest P is very far from the center of the dipole, which means R is way bigger than L. So special case is if R is way bigger than L. In that case, R square will be far more greater than L square. which means r square minus l square will be approximate r square, because r square is a very big quantity as compared to l square. So we can neglect l square. So final answer will be in approximate way r square. So if you will look at it now, E net will look like E net is equals to 1 upon 4 pi epsilon naught 2p into r divided by r square minus l square. In this case will be r square. Okay, r square minus l square will be r square, and r square to the square will be r raised to power 4. Okay, and one of the r factor will cancel out. Final result will be, which is the standard result, final result will be E net is equals to 1 upon 4 pi epsilon naught 2p divided by r cube. This is the electric field at axial position. E axial, we call it E axial. E axial means electric field at a point on the axis of the dipole. E axial is 1 upon 4 pi epsilon naught 2p divided by r cube. And if you will look at its direction, what will be the direction? Direction is towards E1 vector, because E1 was greater. Or you can also say that if you will look at the original diagram, this is minus q, this is plus q. If you will look at the direction of dipole moment, what will be the direction of dipole moment p? Direction of dipole moment in physics is given by negative to positive. So this will be the direction of dipole moment p. And if you will look at the net electric field, that is also in this direction. So we can say that electric field at axial position will be in the direction of dipole moment p, because dipole moment p is in the same direction as we have E net. So one way to comment on the direction of E axial is towards E1 vector, and another one will be towards, or I should say, in the same direction as P, in the same direction as P vector. Okay, so it will be in the same direction as we have the direction for P vector. Are you getting it? But I think first one will be far more better to give the direction, because first one represents the logic also. Like between E1 and E2, E1 vector is a bigger vector. That's why the direction will be towards E1 vector, towards the bigger vector. Let's say if I take this point P on the left hand side of the dipole instead of on the right hand side. Let's say this point P is on this side, on this side. Right now, what do you think? Which vector will be greater? Electric field due to plus charge or electric field due to minus charge? Due to plus charge. बेटे थोड़ा तो दिमाग चला लिया करो. Point P is on left hand side. Point P is nearby to minus Q charge as compared to plus Q charge. Distance of point P from negative charge is much lesser than the distance of point P from the positive charge. So which will give a greater electric field? Negative charge, obviously. So if you will take point P on the left hand side, E2 vector be greater in this case. Electric field due to negative charge will be greater in magnitude, which means final direction will be in the direction of electric field due to negative charge. If you will look at the direction, according to minus Q charge, E will be in this direction. Let me call it E2. And according to plus charge, E1 will be in this direction. And in this case, E2 will be greater. So final result will be in this direction again. E net, yes or no? Yes or no? So we can say that which vector will be greater? Direction of the net electric field be in that vector or in the direction of that vector. If you will look at E net for both the point on left hand side or on right hand side, you will notice that in both cases electric field E, net electric field E, is going into the same direction as vector P. Yes or no? Vector P is going in this direction. E axial on this point is in the same direction, and on this point is also in the same direction. So it implies that doesn't matter what will be the position of point P on the axis, dipole axis, whatever will be the position of point P on the dipole axis, net electric field will always be in the direction of P vector. Yes or no? In the direction of P vector. ये समझ रहा है क्या हुआ यहाँ? इसमें से कुछ नोट करना तो नोट कर लो, अदरवाइज हम आगे कंटिन्यू कर सकते हैं. बोलो, कुछ नोट नहीं करना, आगे चले फिर. ओके ओके, नाउ वी विल ट्राई टू फाइंड आउट नेट इलेक्ट्रिक फील्ड ड्यू टू इलेक्ट्रिक डाइपोल at a point on equatorial axis. And I have already defined what is dipole axis and what is equatorial axis. What is equatorial axis? Equatorial axis is the perpendicular bisector of dipole axis. Yes or no? Equatorial axis is the perpendicular bisector of dipole axis. So there will be a point on the equatorial axis, and we will try to find out the value of electric field on that point. So second derivation is about electric field E on the equatorial axis due to electric dipole. Due to electric dipole. So first of all, let's define equatorial axis. What do you mean by equatorial axis? Equatorial axis is the perpendicular bisector of dipole axis. Equatorial axis is the perpendicular bisector of dipole axis. And now the condition will be, let us consider an electric dipole with electric dipole moment P equals to Q into 2L as given in figure. Okay, and we have to find net electric field at a point on the equatorial axis. So the arrangement will be like this. Let's say this is the dipole. This is minus Q charge and this is plus Q charge. And we have dipole axis. This is dipole axis. And then we have perpendicular bisector of dipole axis. So perpendicular bisector of dipole axis will pass through the center of the dipole. And this will be a line perpendicular to the dipole axis like this, 90 degree. Since it is perpendicular bisector, so this distance will be L. This distance will also be L because overall distance of the dipole is 12. Distance between charges is 12. Now we are interested to find out electric field at a point on this axis. So let's say the point is somewhere here. This is point P, for which we want to find out electric field E. So what will be the direction of electric field E due to charge plus Q from this point P? And remember, the distance of point P is always taken from the center of the dipole. Like in this case, we have taken the distance of point P from the center of dipole, that is R. Same is true in this case. Distance of point P from the center of dipole is taken as R. So this distance will be R. If we will join this point to plus Q charge, you will have a right angle triangle. So this distance can be given as R square plus L square. Let me call it distance X. Same is true for minus Q and point P. Again, this distance will be R square plus L square. We can call it also X distance. Now, tell me the direction of electric field at point P due to charge plus Q. So plus Q charge will repel point P and the electric field will be outwards like this. So this will be the electric field E1. Electric field E1. And minus Q charge will try to attract point P. So this will be the direction of electric field E2. This will be electric field E2. Okay. First of all, let's try to find out magnitude of E1 and E2. So electric field at point P due to plus Q charge is given by E1. What is the formula for electric field? Formula is KQ by R square. So according to the condition, it will be KQ by, what is the distance? Distance is X. We have considered this distance as X. So this will be X square. Okay, direction will be away from point P. Next is electric field due to electric field at point P due to minus Q charge. So due to minus Q charge, again formula will be E2 equals to KQ by distance square. So the value of E2 field will be KQ by distance is again X. In this case also distance is X. So this will be X square. Now if you will look at E1 and E2, both of them have same magnitude, KQ by X square, KQ by X square. So magnitude of E1 vector is same as magnitude of E2 vector. Let me call it, what should I call it? Let's say we call it E. Okay, E नहीं कुछ और दे देता हूँ because E finally use करना पड़ेगा मुझे. So let's say this is Y. Now we will try to find out net electric field. For the net electric field, you have to take the component of vector E1 and E2. And if you will take the component, let's say this angle is theta. This angle is theta. And if you take this axis, if this angle is theta, this will also be what? Theta. Because these two sides are equal. These two sides are equal, x. If this angle is theta, this angle will also be what? Theta. If this angle is theta, from geometry, this angle will also be theta. So everything is theta. Okay. Every angle is theta in this case. Now, if you will take the component of E1 vector in this direction, and remember E1 is nothing but magnitude wise y, and E2 again nothing but magnitude wise y. So we are taking the component of y in this direction. If you are going in the direction of theta, you will use cos, and if you are going away from theta, you will use sine. So this will be y cos theta, and in this direction you will have y sine theta. For the red vector, this will be again y cos theta, and this will be the direction for y sine theta. Y sine theta are in opposite direction, so they will cancel out each other. So let's find out net electric field. Net electric field in y direction. In y direction, there is no net electric field. E net is 0 in that case, because y sine theta are working in opposite sense to each other. This is y direction. Y sine theta in upward direction, y sine theta in downward direction. So these two vectors will cancel out each other. So in y direction, there is no electric field present. So in this case, remember, there is no electric field in y direction. Now we are left with only one direction, that is x direction. That is x direction. If you will complete this as this one, so this will be y axis and this will be x axis. This complete will be y axis. This complete will be y axis, and this complete will be x axis. So in x direction, and if you will look at the x direction, it will be the negative x direction, because this point can be considered as 0, 0. So in negative x direction, net electric field is E net, because both the components are in the same direction. Y cos theta red colored and y cos theta blue colored, both are in the same direction. So we can have E net equals to y cos theta plus y cos theta, that is 2y cos theta. So E net is equals to 2y. The value of y is taken as magnitude of E1 or E2. So this will be kq by x square into cos theta. Now E net will look like E net is equals to 2kq. Value of x is square root of r square plus l square. So what will be x square? X square will be r square plus l square. So in place of x square, we can have r square plus l square. Now we are left with cos theta. So using any triangle, we can find out cos theta. Cos theta is given by base by hypotenuse. So this will be L divided by x, or L divided by square root of r square plus l square. If you will manage it, it will look like E net is equals to k into q into 2l divided by r square plus l square raised to power 3 by 2. Because r square plus l square raised to power 1 from this bracket, and r square plus l square from the other part, which is in square root. Square root means 1 by 2 power. So 1 plus 1 by 2 will give 3 by 2. And dipole moment P is given by Q into 2L. Q into 2L is dipole moment. So in place of Q into 2L, we can have dipole moment P. So we will have the final result. Net electric field E will be K into P divided by R square plus L square raised to power 3 by 2. This formula will be valid for all the cases. Kp divided by R square plus L square raised to power 3 by 2. This formula is valid for all the possible cases. But if you are looking for the special case, Special case. Special case is again same as in the first case we have done. If R is way bigger than L, in that case R square will be far more greater than L square, due to which R square plus L square will be approximate R square. And if you will substitute this value into the expression, E will be K, that is 1 by 4 pi epsilon naught, into P divided by, if you will look at it, R square plus L square is R square, and R square raised to power 3 by 2 will be R cube. So final answer will be R cube. This formula is given for equatorial positions. So we call it E equatorial. E equatorial is 1 upon 4 pi epsilon naught and P by R cube. If you will look at E axial, E axial is given by 1 upon 4 pi epsilon naught. Comparison बाद में कर देता हूँ. First of all, let me give the direction of E equatorial. What is the direction of E equatorial? Yes, if you will look at the direction in the figure, there is no electric field in y direction, and the remaining electric field is present in negative x direction only. If you will look at the direction of dipole moment, it is in this direction P, and the net electric field is going in this direction E. So we can say that direction of net electric field on the equatorial position E equatorial will be in the negative direction of x-axis, in the negative x-axis, in the direction of negative x-axis, or you can also say that direction of E equatorial will be opposite to the direction of P vector, opposite to the direction of P vector. That is also true. Now we can compare between E equatorial and E axial. So comparison between E equatorial and E axial. What is the value for E axial? Magnitude wise, E axial is 1 upon 4 pi epsilon naught 2 p upon r cube. Magnitude of E equatorial is 1 upon 4 pi epsilon naught p upon r cube. If you will compare them, divide, you will get an interesting result. 1 by 4 pi epsilon naught will cancel out, and P by R cube will also cancel out. So you will notice that E axial magnitude wise will be double of E equatorial. This result implies that strength of electric field on the dipole axis is twice of strength of electric field on the equatorial axis, provided on the dipole axis as well as on the equatorial axis point of interest is taken at the same distance. In simple words, if I have point P at 5 unit distance from the center of the dipole on dipole axis as well as on equatorial axis, remember distance is same 5 unit for perpendicular direction as well as for the dipole axis. Then we have 2 points, one point P on the dipole axis, another point Q on the equatorial axis at the same distance 5 unit. Then in that case electric field at point P will be double of electric field at point Q. So for 2 points at the same distance on dipole axis and on equatorial axis, electric field on the dipole axis will always be greater than electric field on the equatorial axis. This is the final result. Any doubt in it? किसी कोई डाउट है यहाँ? Any doubt? Any doubt? आगे चलें। Okay. Next point is what will be the effect of external electric field if we place an electric dipole in the external electric field. First and the important point is external electric field may be uniform or non-uniform. Let us consider the simple possible case which is of uniform electric field E. So we have a uniform electric field E and electric dipole is placed in that uniform electric field. What will be the conditions in that case? So electric dipole in the uniform electric field E. Uniform electric field E. So let's say we have a uniform electric field E. This is uniform electric field E. And a dipole is placed in it. Let's say this is the dipole. And this is minus Q of the dipole. This is plus Q of the dipole. Electric field is uniform. What does it mean by uniform electric field? Uniform electric field. यूनिफॉर्म इलेक्ट्रिक फील्ड क्या होता है ये बताना है. व्हाट इज यूनिफॉर्म इलेक्ट्रिक फील्ड? ऐसे घटिया डेफिनेशन देते ना तुम लोग. यूनिफॉर्म इलेक्ट्रिक फील्ड मींस an electric field for which strength of the field and direction of the field is exactly same at every point of the space. So if we are saying that the given electric field is uniform, it means value of electric field E at this point and value of electric field E at this point will be exactly same. Yes, magnitude will be same, direction will be same. Okay, next point. What will be the direction of force on the positive charge due to external electric field E? What is the direction of force on charge plus Q due to external electric field E? डायरेक्शन पूछी भाई, बराबर ही रहेगा कि क्या सेंस है? towards the electric field. So this will be the direction of force F. What will be the magnitude of this force F? Magnitude of this force F will be Q into E. Yes or no? And what will be the direction of force on the negative charge? It will be in opposite to the electric field. So this will be F. Again, magnitude will be QE. Okay. So if you will look at the arrangement, F1, let me call it F1, and this is F2. Okay. Magnitude of F1 is QE, which is same as magnitude of F2. But if you are going for the vector arrangement, vector F1 will be QE vector and vector F2 will be opposite. So we will have minus QE vector. If you will find out net force on the dipole, net force on the dipole, net force on the dipole. So net force will be given by F vector, which will be F1 vector plus F2 vector. If you will substitute the value, it will be QE vector minus QE vector for the F2. So F net on the dipole will be 0. Yes or no? So what will be the magnitude of F? That will be 0. And magnitude of F means M into A will be 0, which means acceleration will be 0. And acceleration will be 0 means there will be no translational changes in the dipole. If this dipole is placed at rest, it will be at rest. And if the dipole is going in certain direction with some velocity v, it will keep on going in that direction without changing its velocity. Let's say dipole is going in the direction of electric field at 2 meter per second. So acceleration A equals to 0 indicates that there will be no change in the velocity of the dipole. So dipole will still keep on going in the same direction with the same velocity. Or if you have placed that dipole at rest, in that case it cannot move by itself. It will be at rest. Okay. Next point, this is the first part. Second important point is what is the net charge? We have already calculated it. Net charge on the dipole. Net charge on the dipole will be minus q and plus q. So obviously answer will be 0. Third important point is there is no net force, but we have two forces acting on the two different point of the dipole in opposite direction. In that case, there will be a torque, and that torque will try to rotate the dipole moment. So in this case, there will be no translational motion, but there will be a rotational motion. So if you keep an electric dipole at rest, remember electric dipole is at rest in the electric field E. In that case, there will be no translational motion, but there will be a rotational motion. So we will try to find out the value of torque in this case. This is the direction of one line of action of force, and this is the direction of another line of action of the force. And the perpendicular distance between these two directions, if you will try to find out, let's say this angle is 90 degree, and this is the direction of electric field. Let's say this angle is theta. So direction of dipole, remember this is the direction of dipole. Dipole is in this direction from negative to positive. So this will be the direction of P vector, and this is the direction of E vector. This is the direction of E vector. So angle between P vector and E vector is theta. Angle between P vector and E vector is theta. Let's say the length of the dipole is 12. If you will take the component, this component will be 2L sine theta, and this component will be 2L cos theta. Okay. So now we can find out torque. Reason is since F1 and F2 with equal magnitude, with equal magnitude with equal magnitude are working on dipole in opposite direction. In opposite direction. Therefore, they will form a torque. Therefore, they will form a torque. So we are interested in the magnitude of torque. What will be the magnitude of torque? So magnitude of torque is given by perpendicular distance between the line of action of the force multiply magnitude of the force. So tau is equals to, what is the perpendicular separation between line of action? This is the line of action of first force. This one is the line of action of first force. This is the line of action of second force. And this will be the perpendicular distance between them. That is 12 sine theta. So this will be 12 sine theta. Okay. And if you will write down the magnitude of force, that is Q into E. Let's arrange it. Tau will be Q into 2L into E sine theta. So Q into 2L is P. So tau will be PE sine theta. So this will be the magnitude of tau. Remember, tau is a vector quantity, torque is a vector quantity, and again another evidence is we are having PE sine theta. Sine theta in the product indicates that it has to be cross product. So torque in vector form is given by vector P cross vector E. Because P is a vector quantity, E is also a vector quantity, and if their product is having sine theta, it indicates that it has to be cross product only. No other choice is there, right? If it were cos, we will use dot, but it is sine, we will use cross. So torque will be P cross E, and in magnitude it will be PE sine. Any doubt in it? So the main points in this concept is, first one, electric field E is uniform, which means value of the electric field and along with its direction is exactly same at all points, due to which net force on the dipole will be zero. Since net force on the dipole is zero, and if the dipole is placed at rest, in that case there will be no translational motion in the dipole. On the other hand, these two forces F1 and F2 are working in opposite direction at two different points of the dipole, so they will form a torque, and the magnitude of that torque is PE sine theta. In vector form, torque vector will be P vector cross E vector. Understood or any doubt? Net force is zero, net charge is also zero, no translational motion is there, and the final answer will be P cross E or PE sine theta. Okay. If you will look at the results of torque, you will get some interesting facts. Tau is equals to PE sine theta. So what are the parameters which are connected with tau? So you can say that tau is directly related with dipole moment, tau is directly related with E, and tau is directly related with sine theta. So which clearly indicates that greater the strength of electric field, greater will be the torque. Smaller the strength of electric field, smaller will be the torque. And greater torque indicates that faster rotational motion. So if you will have a dipole moment in an electric field with greater strength, in that case, this dipole will rotate at a faster angular speed. So it means omega will be greater. If E is greater, tau will be greater. Tau will be greater means omega will be greater. Omega greater indicates that alpha or the what should I say, angular acceleration will also be a greater one. If you will look at the P factor, P is the dipole moment. Greater the dipole moment, greater will be the torque. Smaller the dipole moment, smaller will be the torque. And from the formula of P, you can understand that it is Q into 12. It's Q into 12. So P will increase if Q increases, and P will decrease if Q decreases. Same is for L. Greater will be the separation, greater will be the P, smaller the separation, smaller the P. So P can be increased by again two different ways. Either you will increase the charge or you will increase the separation. So greater the amount of charge in dipole, greater will be torque, because greater amount of charge indicates greater amount of P, and greater amount of P implies greater amount of torque. And the third factor is sine theta, which again states that if the value of sine theta is increasing, torque will increase. If the value of sine theta is decreasing, torque is decreasing. Okay, what do you think about sine theta? If you are in first quadrant, is sine theta increasing or decreasing in behavior? Increasing. So we can say that if we take the dipole in the first quadrant, which means if I place the dipole with the electric field keeping its angle between 0 to 90 degree. In that case, as soon as I will increase the value of theta, which will be starting from 0. So if I increase the value of theta at 0 degree, 1 degree, 2 degree, 30, 45, 60 and 90 degree, continuously the value of torque will increase. Okay. Now the last point is, from the formula again, tau is equals to P sine theta. Tau is equals to P sine theta. Question is, if let's say dipole moment of the electric dipole is constant, which means I cannot change separation between them, I cannot change the value of charge, and the electric field in which it is placed is also constant, I cannot change the strength of electric field also, but I want to have maximum possible torque. So what should be the angle? So now I want to have tau maximum, because P is constant, E is constant, so we are left with only one parameter, that is sine theta. So to make tau maximum, sine theta has to be maximum, and sine theta is maximum as 1, and that is possible if theta is 90 degree. So torque maximum possible keeping P and E constant will be P is sine 90, sine 90 is 1. So maximum value of torque that can be exerted on any dipole in any electric field will be P into E. Okay. So tau maximum is P into E. Any doubt? So if you want to have maximum possible torque, you have to place the electric dipole at the perpendicular to electric field. If this is electric field E, then dipole should be in this direction. Dipole should be in this direction. This is the direction of dipole at 90 degree. In that case, tau will be maximum, and its value will be magnitude of P into magnitude of E. Okay. What will be the unit for torque? If you are looking for the unit of torque, you can look at the unit of torque from this formula. It is R perpendicular into F. So F will have SI unit Newton and distance will have meter. So torque will be in Newton meter. Remember, if you will look at the formula P is sine theta, you may get confused about the unit, because P and E are not given in terms of Newton and meter. But if you will place their unit properly, the final answer will be Newton meter. So better option is, you will look at the basic formula for the unit. Torque is R perpendicular into F. And in that case, unit will be Newton meter. And of course, its dimension, if you are looking for the dimension will be ML2 T minus 2. Because dimension of distance is L and dimension of force is MLT minus 2. If you will club them, answer will be ML2 T minus 2. Any doubt in it? आवाज नहीं भाई. Question is find the electric field E at a point from the center of dipole from the center of dipole at from the center of dipole at 50 from the center of dipole at 5-meter distance from the center of dipole at 5-meter distance. If dipole moment if dipole moment of the electric dipole is 100 coulomb meter. क्वेश्चन सोल्व करो भाई, ये क्या आएगा आंसर? नया क्या आंसर? Electric field E at a point from the center of dipole at a distance 5 meter. So the distance is given from the center of dipole. It means it will be R. And the dipole moment of electric dipole is 100 coulomb meter. This will be the value of P. And we have to find out uh, electric field E, value of electric field E. So value of electric field E, now the direction of point is not given. So it may be in axial direction or it may be in equatorial direction also. So let's say we have both the cases. First one in axial direction and second one in equatorial direction. So what will be the answer? R is 5 meter, P is 100 coulomb meter, and we are interested in AXL. AXL is given by 1 upon 4 pi epsilon naught 2p upon r cube. So if you will simplify it, it will be 9 into 10 raised to power 9 into 2 into p. P is 100 divided by 5 into 5 into 5. So this will be 4, and you can write it as 9 into 8 into 9 into 8 into 10 raised to power 7 into 10 divided by 5. Now this will be 2. So we will have 72 into 2 into 10 raised to power 7. So this will be 2 to the 4, 7 to the 14 into 10 raised to power 7. So E at axial position will be 1.44 into 10 raised to power 9 and unit of electric field. Unit of electric field, anyone? Newton per coulomb. Second part, we have to find out E at equatorial position. So we have a relation between E axial and equatorial, which states that E axial is a double of E equatorial. It means E equatorial will be half of E axial. So we can find out the value of E equatorial also. E axial is 1.44 into 10 raised to power 9 divided by 2. So E equatorial will be 14.4 into 10 raised to power 8 divided by 2. Now you can divide it simply. E equatorial will be 2 7 the 14, 2 2 the 4 into 10 raised to power 8. Again, what will be the unit? Unit will be Newton per coulomb. नीचे करना चाहिए पहला वाला बुझाना चाहिए मेरा 14.4 into 10 की पावर 9 आते हैं मेरा 14.4 into 10 की पावर 9 14.4 नहीं तो 10 की पावर 9 तो नहीं आएगा 4 4 2 8। अच्छा यहाँ एक पावर कम कर दी मैंने यहाँ 8 आएगी पावर and this will be 8 okay this will also be 8 this will be 10 and then it will be 10 yes this will be 9 this will be 9 okay
अरे नहीं है इसके बाद एक क्वेश्चन फील्ड की सर बड़ा शॉर्ट दे रही है एक फायर नहीं लगाया ना मैंने फिर भी मैंने नहीं लगाया वो ओपन करके मारने ऐसा तो ऊपर के हेड है ये बंदा लगे पहचान नहीं है शब्द भाई तेरी हेल्थ कितनी कम हो गई आधे से ज्यादा क्या लॉन्ग ऑब्वियसली चार बड़ी हाथी का पड़ेगा इसी घर से कर रहे हाँ अयन अयन मार रहे हैं ना नहीं मैं दूर से मार रहा पास में मेरे को बोल रहा शॉर्ट रेंज में और खुद दूर से अरे करंट चौक चले गए
नेक्स्ट क्वेश्चन।
सर ब्रेक हो गया
कर लेना, फिर क्वेश्चंस लगा लेना इसके।
कल आओ ऑफिस
एनसीईआरटी में अच्छे क्वेश्चंस है इसके।
तेरा प्लेयर टेलीग्राम